No problem, man. All right, so let's see what we got. And you know what? We will be done before then, so don't worry about it. Okay, and we are recording. Nice. It's working. I found another way to record, so I think it's going to be better for us. Okay, last time we were talking about the law of sines, and now it's the law of cosines. Now they're very similar. The law of cosine is here, and this is something that you definitely want to box out, star it. This is one of the main ones that we'll use for trig and what we're trying to figure out with triangles here. And the same with a law of sines, the law of cosines we use for non-right triangles. We can use them for any triangle. And I guess you could use it for a right triangle, but specifically we utilize it for non-right triangles. Okay. So the thing about this is the two parts that you have to have in order. If you look here, angle C is on the outside, the cosine of C, right? On this side of the equation, right? On the left side of the equation is side C, and that's what we got to make sure. If we are trying to find information about this angle, right, or no information about the angle, then the angle and side we're relating is big C and little c. So we're going to take, on the very right side will be cosine of angle C, and it's all equal on the left side to the side squared, C squared. Okay, so that's kind of how you set it up. Those two things are involved, the angle and the side opposite, right? The side opposite. And the other adjacent sides here, the other sides, A and B, they fall into place in between. Okay, so there's the C, or if this was B and little b, A and little a, that would be on the outside. The other sides are just in the mix here. A squared plus B squared minus 2AB times that cosine of C. Okay, so it is a little complex, but the main thing to remember is you really just have to remember, as far as the pattern goes, I'm not going to make you memorize the law of cosine formula, but how we use it and set it up, we always set up the angle and opposite side on the outsides, and then what's left over, we just have to adjust from the other sides. Okay. Oh, someone just arrived. All right. So let's see how this plays out, because these are just kind of like, these are just tools that help us just to find angles and sides within a triangle. It's no big deal. It's no big deal. Did that just stop recording? No. All right, so let's look at this. We have this triangle here. It's not a right triangle, so we have to use law of cosine or law of sines. Let's use the law of cosine. And what we're trying to find is f. We're trying to find f right here. Okay. Now, I look and I see the angle that I have information on, right? The angle I have information on and the side involved that I'm looking for are right across from each other. So that's perfectly set up for us to do the law of cosine. Okay, so as I'm setting this up, I just have to be careful to copy down everything correct. And I'm just gonna, you don't have to, but I'm gonna go ahead and copy everything down. Whoop. Because we're just gonna have to interpret it being ABC versus DEF. All right. All right. So in this situation, the main thing to remember is that the angle that we're looking for, or we have information on, and the side opposite are always on the outsides. Really, just look at these other sides are going to fall in between. They're going to fall into this area. Okay. So I just have to be real careful. I'm going to start to input my information. F squared is going to be on the left side. On the very right side, I'm going to have the cosine of what? 29 degrees. And we're in degree mode now because we're dealing with degrees. And then we're going to start to work our way through this. So let's see. It doesn't matter which one is A and B as far as the other two sides involved. So I'm just going to say this one's going to be my A, that's going to be my B. All right, so let's go ahead and put it in. 15 squared plus 9 squared minus 2 times 15 times 9. You might look at that and be like, I hate it already. I hate it. It's okay. We can still do it. Because if I look at this, the cosine of 29, I'm going to figure out right now. It's going to be some decimal. Negative 2 times 15 times 9, I could work all that out, multiply it by whatever that cosine ends up being. 15 squared, 9 squared. See, I can figure all the right side out. It's not going to be a big deal, actually. I could start to fill out what I already know. 15 squared is 225. 9 squared is 81. Minus, let's see, 2 times 15 is 30. Times 9 is 270. And then all I have on the right side here is, well, actually, let's do it. Let's go ahead and find what that value is. Take that back. I take it back. All right, so we're in degree mode. We're going to go cosine 29. And everybody double check that you have this same number when you do cosine of 29. You end up with 0.875. You guys get that if you round it? Just make sure you're not taking for granted that, just putting in the cosine of 29 degrees. First, you got to make sure it's showing you 0.875 so you know you're in degree mode. Okay, so just double check when we're doing these two problems here. All right, and then let's multiply negative 270 times this 0.875 times 270. All right, so we end up with this 225. I'll combine these in a second. Minus 236.15. All right. And this is just a matter of, once you get everything plugged in, you just got to be careful. Just be careful. And let's see, let's go 225 plus 81, get your answer. Then minus 236.15. And we get f squared is equal to 69.85. But that's not quite our answer. I need to know what f is, not f squared. So I have to look and see what will I do to get f when I have f squared. I'll let you catch up, actually. Let you catch up. All right, and then what we're going to do to find f instead of f squared, we're going to square root both sides. So I'm going to take that value I just had. I'm going to go ahead and square root it. And my final answer, because these will cancel. Oh, I usually do it that way. So we're going to get f is equal to 8.36 feet. Done. Oh, what? 236.25. Oh, really? Oh, I know why. I kept all the digits for this. That's why. I kept all the digits instead of rounding it. It was just in my calculator. That's why I end up with a slightly lower value. Yeah. I'm not gonna, if something's off by like a tenth, like what'd you get for your final answer for f? You end up with what? Can you type it in for me? Okay. All right, no worries. So whatever values you get here, remember you're just adding them together. 225 plus 81 minus the 236.15. You might have had 25 here, depending on how you rounded. You get all the way down here, f squared, square root it, and we got our f. All right. Now, I agree. It's a tricky map to follow. The law of cosines is probably one of the more complicated trig laws you can use. But the main thing here is that the outsides are always going to be the angle that you want or have information about, and that opposite side. Okay. So we're going to keep on working on these. The only difference with this one, is we have to find angle A in radians. Okay. So the only difference with this is that we have to find it with radians. So since we're looking for angle A, I'm just going to highlight it so I remember, okay, that's what we're looking for. And then I remember that law of cosine uses the angle and the side across from it. And let's go ahead and, you know what, I'm still going to write it out as it is, and we're going to just see that it doesn't quite matter what the letters are. We're always going to look at it spatially. Spatial. We're going to look at it spatially to see that these values on the outside of the law of cosines is always talking about the angle of interest and the side opposite. That's the easiest way to think about it. If you think about it as in I have to readjust what A, B, and C are every single time, that is the more confusing way. So instead we look at on the outsides are the angle I'm looking for in this case and the side opposite it. So let's go ahead and input, in this case, you know, how I had written it out, C squared and C correspond to A and over here, the side opposite it. So I'm going to go ahead and input some things here. 8 squared. And way over here, I'm going to say, yep, that's the cosine of A. Okay. Again, all I did there was I kept the law of cosines as we had stated it. C squared is equal to A squared plus B squared. But it doesn't mean that I'm talking necessarily about C and C here. I have to focus on using the law of cosine with the angle of interest, or that you have info on, and the opposite side. So that's why I put the opposite side over here, and I put the angle of interest on that side. Now, what's in the middle? All this stuff is pretty much just, think about it, it's just the other sides involved. It doesn't matter which is which. I can make this 5 squared plus 6 squared minus 2 times 5 times 6. You see? So just keep in mind, the only thing you're looking for with the law of cosine is the angle of interest and the side across from it. I'm going to start to work these parts out because we have 64, 25, 36. All this is going to give us negative 60 times the cosine of A. And then, you know, we want to know what A is, the angle A. So we have to start to isolate. And before we do that, let's combine a couple terms. Let's combine this and get 61 minus 60 times the cosine of A. Very tempting to subtract those, but we have to recall that it isn't it's negative 60 times the cosine of A. So we can't just decide to group those together and just combine them. I have to do a little more work. Minus 61 to both sides. Three is equal to negative 60 times the cosine of A. All right, all right. All right, Kaylee. Who came in late? Angelina, Kaylee. All right, I'll get you guys your attendance in a second. All right, I want to get further. I want to get to cosine of A, so I need to divide by negative 60. That's going to cancel our negative 60. Now we've isolated it. Cosine of A is equal to, what is 3 divided by negative 60? Let's see. 3 divided by negative 60. Ooh, that's cool. Negative 0.05. Oh, well. We've arrived here, have we? Let's see. Oops. I'll let you get caught up a second here. 1.62. Oh. Yes, that's right. Excellent. Okay, so this is one new thing. This is one new thing. So I want you to write this next to it. Remember we do opposite operations, right? Operations. When we're trying to solve and we have multiplication going on, we use division. When we have addition, we use subtraction. Remember these? Opposite operations. I mean, that's just how we solve equations. So here is an opposite operation. Cosine and cosine -1. The arc cosine. The arc cosine, right, is like doing the inverse operation. Just like when we had squared value, it was squared and we took the square root, right? It's the same thing. We're going to do the inverse operation because look, we can only take the cosine of angles. So it's not going to help me at this point take the cosine of that value. We can only take the cosine of an angle. In this case, we're in radians. So what I'm going to have to do in order to find what angle A is, I need to do something to both sides here. And first, before we do that, I need you to make sure that you're in Radian mode. You see how on my calculator it says rad? Yeah, maybe you do. Yeah, radian. Look how good that is. And if you push the DRE button, you can see it goes to gradient, it goes to degree. Make sure it's in rad, radian. Okay? Because we need to find our answer in radians. So this is the last step, and we're going to practice this very last step a few times, okay? Watch this. I want you to do the cosine inverse to both sides. The inverse cosine to both sides, okay? It's also called the arc cosine. Arc is the negative version of it. So it's just like the inverse, just like the opposite operations. The inverse cosine of cosine, when I do that, watch what happens. It crosses out my cosines. So essentially, we're going to figure out what A is equal to if we do this part on the left side, if we do this. Okay? So I want you to try to get that in your calculator. You're in Radian mode. Try to look on your calculator and find where that cosine -1 is. It's behind the cosine button. You're going to go 0.05 negative, and then you're going to go second cosine. Yeah. Yep. Yeah, so let's do that again. We're going to go, mine, I have to do 0.05 negative, right? I have to push negative after. I'm going to go second, cosine, and then I get the radian measure, okay? So what we ended up here is we end up with 1.62 radians. That is the measure of this angle, okay? So the answer was in radians, but it's no big deal. It's just like if we had, the answer in degrees, that would probably be easier for us to see. 1.62 radians is like it's close to 90 degrees. It's like 92 degrees, 91 degrees, something like that. All right. This last step, I think we just got to practice a couple times. So what if I had this? Cosine of B is equal to negative 0.25. So find B in radians. So we're going to just do a couple of the last exercise that has us use that arc cosine, that cosine -1. So we'll do these couple of questions here. Cosine A is equal to negative positive. Okay. So how about this? I want you to try to solve for B in radians And then I want you to solve for this. Find A in degrees. Okay. So we'll do radians and then we'll do degrees. If you're not sure where to start, no worries. I cannot take the cosine of an angle I don't know. I have this other information that's related to the ratio of the triangle. So what I'm going to do is I'm going to take the inverse cosine of both sides. And as long as you're in radian mode, make sure you're in radian mode. When you do so, it cancels out this cosine. We get B is equal to. And then we just have to work that out. We have to work out what is that inverse cosine of 0.25 negative. So the measure of angle B in radians. Actually, why don't you put that in the chat? What is the measure of angle B? I need a few of those answers in the chat. What is the radian measure? Excuse me. Radian? Woo. Yawn came out of nowhere. What is the radian measure of B? Nice. Good, Dave. Good, Alicia. Anyone else want to throw that in there? The measure of angle B? Good, Brian. Okay. When you take the inverse cosine of negative 0.25, you're going to end up with 1.82. Make sure to label it radians. You got to say it's radians. Otherwise, I might think it's like a really small angle, like 1.82 degrees. Not the same. Okay, lastly, for this one, remember it has to be in degrees. So change to degree mode. And we're going to do the same thing. Degree mode. You got it, Joshua. Perfect. Yeah, go ahead and give me the degree mode. Alicia, I think you're in radian mode still. You're in radian mode, potentially. Make sure you're in degree mode. And then go ahead and work it out, guys, and throw your answer in there. Good, Dave. Perfect. Wait, are you in that mode? Let's see. Yeah, you were in radian mode. So just change that out. That's probably like the trickiest part is organizing it and then making sure to switch between radian and degree. All right, when we do that, look, these cancel because they're inverse. And we get A, the measure of angle A, is going to be equal to, in degrees, I'm in degree mode, notice, degree mode, DEG, and I'm just going to go 0.75, right? Second and cosine, so we get the inverse cosine, and we get 41.41 degrees. Nice. It's just a function. It's just good, Alicia. Perfect. It's just a function to solve when we get to this point. Because remember, the trig functions only work with an angle, so we can't take the trig function of the ratio. We have to do the inverse to both sides, and that'll allow us to isolate the angle. Mm-hmm. All right, guys. Give it to me on a scale from 1 to 5. How about accessing the law of cosines? On a scale from 1 to 5, what do you think? Yeah? Okay. Yeah. Mm-hmm. All right, got 4s and 5s. Cool. Good. All right, you're going to have a good amount of time for this one as well. Let me go and stop the recording. And it doesn't want to stop. It says, no, I will not stop. Stop.